Hello, BISD students, parents, and educators. My name is Nikisha Burns, and I am the Public and Government Affairs Manager here at ExxonMobil Beaumont. First, all of us here at ExxonMobil Beaumont hope you and your families are staying well and safe. Every week, we will come to you on Thursdays with our stay-at-home STEM activity. This week's activity will be extremely fun. We are excited to partner with the Beaumont Independent School District. Today's experiment, which I know you guys are all going to enjoy, is a rubber band powered car. So how cool is that? At this time, I will turn it over to my two colleagues, Elise and Luke, to take it from here.
Hi everyone, my name is Elise Welsh. I am an environmental permitting advisor here at the Beaumont Refinery.
And my name is Luke Wynn. I'm an approved group co-op here at the refinery, and I'm from Lamar University.
So just like Nikisha said, today we are going to teach you guys how to build a rubber band powered car. We're going to be learning about kinetic and potential energy. Luke, can you tell us what kinetic and potential energy is?
So the difference between kinetic and potential energy is that potential energy is stored energy, and kinetic energy is the movement that is released whenever you release potential energy.
Luke nailed it on the head, you guys. So potential energy is going to occur whenever you have an object that's either stretched or compressed beyond its natural form. And a great example of that is a rubber band. So the more I stretch my rubber band out, the more potential energy I store in it. So that way when I release it and it springs back into place, that's releasing the kinetic energy. And that's what we're going to capitalize on when we build our car today. So I'm going to hand it over to Luke. He's going to start us off with a quick safety moment because some of these materials can be a little bit hazardous if you're not careful.
All right, so the dangerous materials that we'll have today, starting off with a skewer. So skewers are made to stick through things, and so hopefully the only thing that you stick it through is the straw today. And so you want to have your parents' permission to make sure that you have wooden skewers. If not, you can use other materials that will substitute. And then as well as
keep that pointy end faced away from you
always
too.
Away. As well as we're also going to be using scissors, and same thing applies with that. And then hot glue. So for this demonstration, we'll be using tape instead for the demonstration. But if you wanted to use hot glue to make it a little bit stronger, just make sure that you don't get it on your hands. And if you do, just make sure to cool it off.
Yep.
Alright, so we'll start with our base. As you can see, we have different shapes. For me personally, I like the square shape, makes everything easier to line up. But you can use different shapes, whatever you like. And so we'll start off with taping the straws on different ends of the cardboard.
And if you guys don't have cardboard available at home, you can use something else, maybe a piece of plastic that you'll easily be able to cut with some parents' help. You can use a piece of styrofoam. You can maybe even build your own base out of popsicle sticks or anything else you guys have lying around. Your creativity is your own limitation here. Make this car yours. That goes for the wheels as well. If you don't have CDs lying around, maybe you have some bottle caps you can use. Jars from peanut butter would be a great thing to use as well for these wheels. Just look around your house, get creative, find whatever you can to make these cars.
Alright, so now you have two pieces of straws connected on opposite ends. And so your next step is you're going to use your skewer actually to poke a hole in one of the sides. Shouldn't be in the middle, it should be off to one of the sides.
Be very careful, get a parent to help you if you need it.
Alright, and so now we'll be assembling the battery, or the rubber band engine. So you're going to take a paper clip, you're going to stick the rubber band through and have it like this, to where you can pull and have that kinetic or the potential energy. And so now you're going to stick the pointy end of the paper clip in that hole you just made. And I'll explain what this is for later. Alright, so now you're going to take your pair of scissors, and on the opposite end of that, kind of cut out a piece of the cardboard. Alright, so now you're going to stick the skewer through the open end of the straw.
Oh, you lost it.
So now, whenever you have wheels attached, we won't be doing that part because it's kind of tricky. And so we recommend that you sort of try it out on your own by making the wheels. So you'll take the rubber band, you'll sort of attach it to the exposed part, wrap it around a couple times, build up that potential energy, and whenever you release, that'll be your car moving.
And we do have a couple of models to demonstrate this for you guys, so you're not having to imagine the finished product. So the first one I want to show y'all here, this uses that kind of trapezoidal demonstration that Luke showed you earlier. So you can see we've got our wheels here at the front and the back, and that exposed axle that Luke had you guys made, and our engine as well. So just like Luke said, we're going to pull this one back. We're going to get that potential energy stored up. You're gonna wrap it around that axle a couple of times, just as much potential energy as you want to store up there without snapping it. And then whenever you let it go, your car goes forward. So there's a couple of interesting things about this design that I want to point out for you. The first one is just on our wheels here. You see how I have all these rubber bands around there? Why do y'all think that is? It's because if we're gonna put these slick Sea-Doo wheels on a slick surface like this, it makes it very hard for it to grip it. Your axle may turn and your wheels may turn, but your car might not go forward. So if that happens to you, you just need to get a little bit of traction, right? Wrap a couple rubber bands around there. Maybe add, I attached some quarters on here as well to give it a little bit more weight to help it get that traction, to help that car go forward. Maybe you have too much weight on your car. That could be a problem. Well, here is another example that we built up for you. This is much sleeker design. We didn't use any cardboard or anything for our base. Instead, we built a base out of some skewers. We only have one wheel in the front here and then two more wheels in the back, all of them built out of bottle caps. These are all attached with some molding clay too on the inside. So you don't have to use hot glue. You can use whatever you guys have around the house. Play-Doh works really well as well. And so for this one, same concept. We're just gonna take that rubber band, stretch it out, wrap it around that axle a couple times. And this car's really gonna take off, so get ready. There he goes. And that's the experiment. Thank you guys so much for having us.
Thank you.
Thanks again for joining us today for Stay at Home STEM. I know I have thoroughly enjoyed today's activity, and I hope that you have enjoyed it as well. Again, here are the cars. Here's the second one. So, we want you guys to post photos of your Stay at Home STEM activity. Let us see your car. Post your video, or not your video, post your photo in the comments section on the video, and we will share it with our audience. I hope you have enjoyed today's Stay at Home STEM session. We look forward to seeing you next week. Until then, stay safe and thanks for tuning in.